Technology is driving and changing the way we live and learn and work. We need to make sure that we're ready to change with it, and I know this facility will help make that happen.
I guess we might as well start right here, right? So Stared is a great partner of us for precision measuring equipment. So obviously everything in manufacturing has very tight tolerances that have to be measured and quality controlled. That type of skill set and the instruments that are needed to do that happen right here. So Stared's been around for almost 140 years. They're, like I say, they're the industry standard. So we make sure we use their equipment and we teach their curriculum through a national certification program designed by them, vetted by industry, that our students then earn. So when they go out and look for employment, they have not just a gateway credential, but also that industry recognized certification credential to help them get a job in these very high technical areas that are very much in demand. So
data analytics is what's driving business to improve quality and improve customer service. So that's what these guys are actually, there's two instructors up here that are actually running through some code right now, and that's what they do. We have servers around the corner that's flying those large amounts of data. I'll give you an example. In an 8-hour shift, Foxconn has told us that's 32 terabyte of data in an 8-hour shift. That's more data than I probably will do in my entire lifetime, but they're doing that in 8 hours. And then what our people have to do here is dig through that data to find out what's happening with the equipment and then visualize that so that they know a technician can go out and repair that and make adjustments. Very cool technology. This space we're in right now is what's called really a automated smart factory using Industry 4.0 standards. And Industry 4.0 means we've taken everything that we've learned in 3.0 and now you'll see everything's connected. You'll also see all kinds of new things with robotics, with AGVs, which are the automated guided vehicles that are running around here. He's right here.
That little one with the green that will actually come out and drive itself around.
You'll see all kinds of smart sensors and sensors in the manufacturing lines. So that's what this is all about. It's that culmination of electrical, mechanical, data, cybersecurity all in one.
Directly tied to the data analytics program. I mean, it was on purpose that we have just a glass door in between here because the engineers and the technicians down on the factory floor have to be directly tied and working with the IT folks that might be up in an office or a cubicle somewhere in a manufacturing setting, but they're always working together to make sure all of this is functioning properly. That's the part that you don't see. You'll see the other names on this wall, including Fanuc, Amatrol, Lab Midwest. They've helped us put this one-of-a-kind simulation center together to make sure we don't just educate our students on all this high-tech skill sets that they need, but it's also for our community. So the community can come in here and see what literally Industry 4.0, kind of a lights-out manufacturing process would look like, obviously on a mini scale. But you'll just see this at a much grander scale if you go to an SC Johnson or a Foxconn, or really any of today's automated factories. They're working with very similar principles like this.
You'll notice there's Z-Space along that side and our augmented reality along this side. So we can use this for our students to do a couple of things. Number one, when they design and develop a building or a space, such as the soccer field for out at, say, Case, they can take that soccer field and walk through it and find out if there's any design issues. They can also then, if we're developing a product and manufacturing a part, we can bring it right into this software, pull it up in 3D, turn it, rotate it, and actually find a flaw in it before we print it. Because we used to 3D print it right away, well that takes 6 to 8 hours. This takes that out, you can correct it, and then print it, make sure it fits all your materials, and then send it out to the factory to actually produce it. So it saves a lot of time. It's actually fun software for our students because it's not often you get to actually visualize in 3D an actual part you just created in a software package. Very cool stuff.
And from that 3D model, they can use a variety of 3D printers here to basically make an actual replica of that. So we have 2 carbon fiber printers in this area, which are actually able to produce some actual quality parts that can be used not just for prototyping, but actually in actual usage. So this is a bit of an expanded space in the new iMet Center. So we've had a fab lab for a long time, but we've expanded its capability and its overall footprint a little bit. So this is where they can take, again, all the 3D modeling that Ray was talking about in the virtual reality lab, as well as all of our other CAD labs, and this is where they can actually come out and actually prototype it. So you'll see a variety of Dremel 3D printers, as well as a few other brands like Affinia. And again, we work with our partners, whether it's First Technologies, Dremel, to really make this happen.
Graphics students get really excited about this, and they build a live demonstration of what a character would look like. They do that, and again, small to large, showing you the capabilities of our largest 3D printer. So this is our freshwater lab here on this side, and one of our instructors is here. Steve, you want to explain what you do on this side?
Sure. The whole purpose of this classroom is to break things, basically. So we make concrete, as you can see right here. This is just a concrete mix bag, and we sifted out all the different sizes of particles that go into a concrete mix. And so we test them, we make it, and then we break it to see what the strength is or how it performs. So we do that with soils, we do aggregates. The whole idea is to get a feel of how all these materials work so that we can make our civilization function a lot better, knowing how the material actually works. And this is our freshwater resources expert, Dr. Michael Schrader.
What we've been doing all semesters, we've been testing different water sources. And there's certain things that we're looking for. You want to see what's dissolved. You want to see biological organisms. So we've got different samples. So just because something looks like it's clear, may not be clear. So this looks very clear. This looks more murky. This is directly out of Green Bay. This is actually cleaner than this. These two here, for example, one is from that tap, one is from that filtered water, almost no difference in what we're doing. We've been testing different filtration products, kind of mythbusters, what works and what doesn't. So we've actually been running water samples through. This is city water, for example. You see it's got that like little white milky. That's actually what's in city water. So we put alum in there and it'll precipitate that out. Meets all standards. Racine water is considered the best of all. We don't really think about what's in our water. So we've actually took some water from the yard a few weeks ago, filtered it out, distilled it, and drank it to create a process that we can actually create drinkable water without having to use electricity, just using things like lime juice, salt, alum, and we can actually filter this stuff out using clay pots and charcoal and make it drinkable water, which is a really cool thing to know, because if you have a crisis or an emergency and you lose power or you lose your water supply, that you can go out and make your own drinkable water.
It used to take us 3 to 4 weeks before students understood what a contour was or a digital train model. And now, if you come in here and we can come up, it reprojects the contours directly onto the sand surface instantly. So now instead of 3 to 4 weeks, it's 3 to 4 minutes before students actually have a contextual feel of what a contour is. And not only that, but we can simulate hydrology and have the water flow. We can come out here and we take pencils and we decide where to put for survey points when we have to go out and create this electronic model.
And this is the Rockwell Automation Lab, and you'll see Rockwell's names there, but these are all what's called PLC controllers, and they actually help our students learn how to program PLCs along with motor controls, and different logic, and HMIs, which are human machine interface. So that allows them to do that. Now, here's the thing. Once you do that, you got to be able to control something. Well, that something's on the other side of the lab, and they actually will start a process here and make sure that they can connect to the other side like they would in a real manufacturing plant, and make sure it's working the way they thought it would. And they can also spot errors here, correct some of those errors without even leaving here. And this is really what's happening in industry now, is you're seeing less and less of the tech running out there, more and more of the tech working here.
Another simulated center where then students can practice the programming side of it, which is more the electrical side of it, but then obviously you have to mechanically typically do something for a process. They get to come over here and then troubleshoot and diagnose that system over here. We're able to train their employees on site. It's more convenient for them, so the technical college system and Gateway provides that service to our local employers. Again, more portable cases that deal with hydraulics, pneumatics, and other electrical controls that help drive a lot of the mechanical systems that you see. We obviously use it for our students here, but again, it allows us to take it out to local high schools, do demonstrations, as well as local businesses. Say, in fact, I think Incinerator here was this morning, training on some of this very similar equipment.
And here you'll notice they have just blank red boxes basically here, where they can bring out motors, they can actually put pulleys on them, they can do bearing alignment, they can do belt alignment, and all of their stuff is in little drawers that they actually can pull out and put together here so that they can replicate what's really happening, say, on an assembly line.
What we'll end with is the FANUC, robot world essentially out here, but this FANUC simulation room, as you can see, basically has virtual robotic arms. So before a student goes out and actually starts to program the real thing, they use the exact same piece of equipment, that teach pendant, what it's called, connects to the PC, and they can literally program that virtual arm just as they would when they go out and see it for real when we step outside here. We're also a partner with FANUC in their ZDT technology as they begin to roll that out here in the near future. ZDT is zero downtime, so these robots are connected, again, part of the Industry 4.0 big data set. These robots monitor themselves and they will actually predict their own failures. So the idea is, in any manufacturing type environment, you don't want an unscheduled or unplanned downtime. That affects productivity, margins, costs. These robots will actually predict and warn, literally like email the technician, I might have a problem, here are some things you should check at, and let's do that within the next couple weeks before a potential breakdown actually occurs.
We'll also be using that data, that large amount of data collected, in our data analytics program so that it's continuously used. Industry 4.0 is all about data.
So a lot of people think of robots as just, moving from point A to point B. And robots can do that, and you can program to do that. But robots can also be programmed using different type of systems, more artificial intelligence type of systems like vision. So in this case, the robot will actually be able to sort by color the different, say it was pharmaceuticals or pills or candy or whatever else. It will actually be able to do that without you telling it where exact every color or every item is. It can actually see what's going on and then pick and place those items based on the programming that the students will create and then input into the robot itself.
Sometimes you'll see gates like we have around those to actually protect the person. In this case, we have proximity devices that actually alert it that we're coming closer, so they stop. When you pull back a ways, you'll notice the light will actually change from red to orange when we're not around it, and there it goes, and then it'll actually start again. We have to help industry move from Industry 2.0 to 3.0 to 4.0, and it doesn't happen overnight. It takes upskilling of all the people that are involved, and that's what this center is about, is upskilling those skills so that they can move to Industry 4.0.
And making sure our community knows what advanced manufacturing looks like. It's not the black and white, dark, dirty, dangerous job. You walk into today's manufacturing centers, they are neat, they are clean, they are organized, they are high tech, and you have a wide range of skill sets, from your traditional machinists and technicians all the way to engineers and IT professionals that are keeping all of this running and going.